Yeah, Assalamu alaikum, everyone. Welcome to lecture 7 of natural language processing. So, in the last lecture, we had started talking about IR system or information retrieval systems, and we discussed the representations required for documents as well as for query. And then we also discussed how to score the documents given a query. And subsequently, we started talking about the evaluation of IR systems. So we will start with the evaluation of IR systems today, and with its conclusion, we will then move on to text classification, and specifically we'll start talking about logistic regression as a text classification technique. So we'll go over logistic regression and then following that neural networks relatively quickly because I guess most people must have studied it at least at one place before this class. So, but of course, both these techniques are foundational techniques, and it is always necessary to refresh ourselves with these techniques, and they are kind of the building blocks for neural networks, more complex neural networks. So, so with that, are there any questions? Any questions? All right. So, so this slide basically describes the flow chart for a standard, or you can say traditional information retrieval system. Such systems are still used in many applications. Of course, in the previous days, in older times, this was the mainstay of almost all information retrieval systems, including web search. But nowadays, this has become more complicated and it has also evolved with the advent of dense embeddings as well as with the advent of generative AI, which we'll also discuss later on this course. Uh, so as I said, this is the traditional IR system, which is still usable in many applications, like, for example, email search on your desktop or product search on a e-commerce site and so on. So basically, we have a collection of documents. Documents, as I mentioned earlier, could be anything, tweets or emails or articles or product pages, whatever is your unit of the larger unit of interest. So those documents are indexed, and the index that is typically used is what is called as an inverted index. So inverted index we did not talk about in great detail, but it's very, very simple. So it's a list of words that typically occur in the documents, which is the vocabulary. And for each word, you have the list of documents. Those are called the postings. So from this inverted index, you can actually regenerate the TF-IDF of each document because each document and the words that it contains can give you the TF-IDF values of that document. So the inverted index leads to a representation for each document. And of course, the inverted index is a database and of course, an efficient way to look it up. On the other side, you have a query, which is usually furnished by a user. The query is also posed as a set of words or whatever your smallest unit of interest is. And those queries is also represented as a vector, the Q vector, and we have a D vector. Both of these are vectors in vocabulary dimension space. So both of them are in basically the vocabulary dimension space. Then you take the cosine similarity. The cosine similarity will give you a score between 0 and 1. The higher the score, the more relevant that document is for a particular query. And of course, the scoring function can have additional aspects, as we mentioned last time. And based on the score, you rank the outputs, and those outputs are then shown to the user. So more complex IR system may have a feedback loop. So what is known as relevance feedback. The user may give feedback to the system and the system may adapt with time. So we are not going to discuss those steps. And of course, more complex systems may have more sophisticated query processing. Okay? So the inverted index is actually a very simple thing. I really didn't want to go into that, and something that you should look into your own. So let's say if you have a vocabulary with three words. So let's say the word D. So let's say we have a vocabulary of word. Let's say good. Let's say excellent and good, and then D. D. So the inverted index is simply a list of words, right? Excellent. And then we have of course, this would be sorted or indexed in some way, usually a hash table or hash tree. Okay. And then after that we have, of course, index में यहाँ sorted लिख रहा हूँ, उसको good है दूसरा word, and तीसरा word D है. So for each word, then we list the documents that contain that word. So let's say excellent is contained in document D1, D3, and D4. So this list after each word is called a posting. But this posting can be more sophisticated. It can be more than just the name or index to the document. It could be also tell you how many words this uh, occurred in this document. So for example, action occurs twice in this document. So you can write that. So in D3 it occurs 1. So in this, let's say it occurs 5. And of course you can add additional things. Position भी add कर सकते हैं, additional information भी add कर सकते हैं. So good में let's say ये भी D1 में है and D5 में है, let's say D5 में let's say 2 है, D1 में let's say 1 है, and that's the D1, D2, D3, D4, and D5. So this is how a inverted index looks like. You can say schematically. How it is implemented is usually a hash tree. It's a database that you can look up each word, and for each word you get the list of documents and associated information. From that associated information, you can then develop the TF ID of that document. Okay. Okay, one quick question for you guys. So what is the size of, let's say, Q is a vector and D is a vector. Q is a query vector, D is a query vector. What is the size of both of these vectors? Anyone quickly? Uh, you can mention it in the context of this small example or in general. So Q and D are both vectors. And okay, so the vocab size. The vocab size is usually very large, and both these vectors are sparse. Which one is usually more sparser, Q or D? So Q is more sparse. And again, for those who don't understand, sparsity means that if you have more zeros, then it's more sparser. So Q usually will have maximum a few keywords. Whenever you ask a question is usually very small, the document is usually very large. So Q would have few words that are non-zero, the rest would be zero. So Q is sparser. So whenever you want to compute the score for Q and D, do you can rely upon sparse processing or sparse multiplication or whatever your approach is to do this. So let's say जब आपने कोसाइन निकालना है Q और D का, So should you go ahead and multiply the entire vectors, or what should be the easier way to do that? Anyone? जब आप basically what happens in inner product, you have a inner product Q and D divided by, of course, the norms of Q. ठीक है ना? So inner product ऊपर जब 0 0 मल्टीप्लाई करेंगे 0 होगा, 0 1 मल्टीप्लाई करेंगे 0 होगा. Only one you will get some value which is non-negative when both Q and D have non-negative values or non-zero values. ठीक है? तो वो the minimum size is Q. So Q की जो नॉन जीरो वैल्यूज हैं उन्हीं की कॉरस्पॉन्डिंग D की वैल्यूज के साथ आपने मल्टीप्लाई करना है. दैट्स इट. So this processing is actually very fast. You don't need to multiply the whole huge 10,000, 20,000, 100,000 vector with each other. Simply 5-6 जो points हैं of Q, you multiply with the corresponding points of D. ठीक है? And the inverted index will help you in doing this, because you can find right away those words and the documents. You don't have to create the complete vector. ठीक है? Of course, creating the complete vector would be necessary in future analysis, let's say in text classification, but इस IR system के लिए you can optimize it by simply looking at those words that appear and ignoring those words that do not appear. ठीक है? All right. So any questions so far? So we discussed various evaluation techniques last time for IR systems. Uh, आपका क्वेश्चन क्या था? कौन सा वेक्टर? क्यू और डी दो वेक्टर्स हैं, और कौन सा वेक्टर की बात हो रही है? ऑलराइट. अच्छा. So the Q, I don't represent which vector you're talking about. You're representing vector Q. So Q represents D is the document. D is the document, represent a document. Q represents a query. ठीक है? So one query, and then you have to check against all documents, and cosine would be for each document and each query. And based on this, you rank the documents. All right. So in the last class, we talked about various measures, and I'll explain these measures with example. Hopefully, everyone would understand and follow me. So precision, recall, and of course F measure भी होता है इसके बाद, which we did not introduce last time. Of course, this can be done for one query. This can be done for multiple queries. ठीक है? Then we talked about reciprocal rank. This can also be done for one query. If it is done for multiple queries, then it was mean reciprocal rank. ठीक है? Then we talked about ranked precision or precision at rank K. This can also be done at multiple queries and mean rank precision. And then the last one, mean absolute precision. This is for multiple queries in general. Of course, AP आप कर सकते हैं for one. लिख लेता हूँ मैं AP, but it's less commonly used. And mean average precision for multiple queries. So let's take a simple example and we will go over these numbers quickly. So let's say you have an IR system and you have a query. ठीक है? कोई भी query है. उस query की जो output है वो आपने evaluate करनी है. ठीक है? One query. लेट्स से Q1 कह देता मैं, ठीक है. So we mentioned two sets last time. RT is the relevant set of documents, which is the gold truth, and RD is the retrieved set of documents, which is output by the IR system. And this RD is usually ranked because scoring system would help you rank the documents. Most highest score would be number one, second highest score number two. So rank of relevant docs. So let me write the ranks of the relevant docs. So let's say the first relevant doc occurs at rank 2, then 3, then 5, then 8, and let's say 12 and 15. ठीक है. So ये हमारी IR system ने ये output किया. The number one output was not found to be relevant. The second was relevant. The third was relevant. Fourth was not relevant. Fifth is relevant. 6, 7 not, 8 relevant, and so on. ठीक है. So what does this mean? RT जो है, this is equal to 6, right? And what is RD? Can anyone tell me what is RD? कि retrieved कितने documents हमने maximum किए हैं so that we can retrieve all relevant documents in this particular example, of course. The last relevant 15, right? So the last relevant document was retrieved at 15. Okay. So this is a setup for one query. अब मैं थोड़े से precision recall निकालता हूँ इसको. So we are the first relevant rank was 2, 3, 5, and then 8, and then we have 12, and then 15. So 2 का recall क्या होगा? So that is just one found out of how many? 6. So this is a recall, and precision क्या होगा? 1 found out of 15. ठीक है. Of course you can multiply these numbers with 100 to get percentages. तो ये पहला आपके पास recall precision की वैल्यू आ गई. F1 भी निकाल सकते हैं आपके. F1 is basically precision into recall divided by 2. 2 times precision divided by precision plus recall. ठीक है, वो आपको फॉर्मूला मिल जाएगा नेट पे. So what about this second? कोई मुझे पढ़ सकता है? What would be the recall? हमने rank 3 पे recall क्या होगा? How many documents have we seen? How many relevant documents? 2/6. ठीक है ना. तो ये precision हो गया, recall हो गया, and then the precision will be 2/15. ठीक है. तो इस तरह आपका निकलता जाएगा. लेट्स से मैं 8 का निकाल लेता. 8 का निकालते हैं तो ये अब हमारे पास कितने डॉक्यूमेंट्स निकल आए हैं हमारे पास? 2, 3, 5 and 8. This is 4/6, and then we have 4/15. So you can plot all of these numbers, precision and recall, as a precision recall curve. So you notice that uh, as the recall increases, as the recall, as the recall increases, the precision decreases. ठीक है. एक सेकंड. So for example, at this stage, the recall is basically 0.6, and the precision is 26.26. Okay. So this will be the general trend, and we plot इस तरह का कुछ आएगा in general. So this is for one query. पर वन क्वेरी का हम वैल्यूएशन नहीं करते टिपिकली आईआर सिस्टम्स के. तो वी टिपिकली वैल्यूएट ओवर बाय टेकिंग एवरेजिंग ओवर मल्टीपल क्वेरीज. अब इस केस में मल्टीपल क्वेरीज में क्या होगा, उसमें एक इश्यू आता है. लेट्स से आपका क्वेरी 2 है, लेट्स से Q2 है आपके पास. तो लेट्स से Q2 के भी रैंक्ड लिस्ट जो है, लेट्स से वो आपके पास आती है, लेट्स से लेट मी से 3, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 5. So this is 6. So again, we have found that the relevant documents for Q2 is also 6. So आपके पास वो जो ऊपर जो रिकॉल की वैल्यूज हैं वो एग्जैक्टली वही आएंगी. पहले कोई वो होगी, दूसरी की वो होगी, तीसरी की भी वही होगी, बट प्रिसीजन डिफरेंट होगी. सो आपके पास ये दूसरी क्वेरी है तो प्रिसीजन की आप एवरेज लेते जाएंगे. So if this is the case for all the queries, then that's very easy. तो आपने precision की average लेनी है, you plot one line. But the issue would arise when let's say कि आपके पास जो query है, let's say Q3 है, Q3 में जो relevant documents हैं, RT let's say 10 है. हो सकता है ना, so for different queries number of relevant documents is different. So in this case जो रिकॉल की वैल्यूज हैं वो एग्जैक्टली वो नहीं होंगी. पहले पोजीशन के रिकॉल की वैल्यू 0.1 होगी, दूसरी की 0.2 होगी, तीसरी की 0.3 होगी, एंड सो ऑन. सो हेयर यू नीड टू मेक अ जजमेंट. जो क्लोजेस्ट वैल्यू है जो पिछले के साथ, उसके साथ की प्रिसीजन निकाल के वो एवरेज ले, एंड प्लॉट दैट, एंड इग्नोर द मिडल वैल्यूज. या मिडल वैल्यूज को प्लॉट कर दें फॉर दैट, बट उसको इंटरपोलेशन के लिए यूज कर लें. ठीक है. So this can happen. So for this you basically take the nearest recall, और उस nearest recall का precision लेके बाकी सारी उस recall की precisions के average लेके plot कर दें. So this would be for multiple queries, and you will get one plot for multiple queries for one IR system. Let's say if you have two IR systems, तो दो plots होंगे. And usually a plot which is higher. So closest recall is something that you may have to make a judgment. So let's say ऊपर हमारे पास हमारी पहला रिकॉल था 0.16 था, राइट. तो दूसरा 33 था. ठीक है. अब लेट्स से आपके पास 10 वाला सिस्टम है, तो उसके पास आपके पास क्या आएंगे, 0.1 होगा, एक आपके पास एक 0.2 होगा, 0.3 होगा, एंड 0.4 होगा, एंड सो ऑन. ठीक है. आपके पास पहली वैल्यू ऊपर रिकॉल की 0.16 थी. सो यू प्रोबेबली टेक द क्लोजेस्ट वैल्यू हेयर विच इज 0.2, और 0.2 के जो प्रिसीजन आएगी वो उसकी प्रिसीजन में एवरेज करेंगे आप. सॉरी. So these are the recall values for if you have 10 relevant documents. So for the first relevant document, recall would be 0.1, the second will be 0.2, and so on. So we will have to match the recall to take the averages of PC. आपका क्वेश्चन मुझे वैसे समझ नहीं आया. कैन यू जस्ट स्पीक आउट, क्लैरिफाई क्या करना है मैंने.
सर वो जो आर डी आपने ऊपर लिखा हुआ है इज इक्वल टू 15, बस आर डी एक बार बता दें क्या है.
RD is a set of retrieved documents जो आपका सिस्टम
ओ,
रिट्रीव करता है. RT
और
is the set of relevant documents. तो आर जो है वो रिट्रीवल और रेलिवेंट के लिए दोनों सेम है. लास्ट डिजिट को यूज कर रहा हूँ टू डिस्टिंग्विश बिटवीन द टू. आर डी वुड बी रिट्रीव्ड विच हैज अ डी एट द एंड, आर टी रेलिवेंट विच हैज अ टी एट द एंड. ठीक है.
सर एक क्वेश्चन है जो मल्टीपल क्वेरीज में हम प्रिसिशन की एवरेजिंग करना चाह रहे हैं, उससे पहले जो क्लोजेस्ट रिकॉर्ड देख रहे हैं, तो वुड वी हैव टू कंप्यूट द क्लोजेस्ट रिकॉर्ड फॉर ऑल ऑफ द क्वेरीज, यानी कि वो कंप्यूटेशनली एक्सपेंसिव नहीं हो जाएगा?
वैल्यूएशन तो ऑब्वियसली हम सारों के लिए करेंगे, अदरवाइज तो वैल्यूएशन किस तरह निकलेगी हमारे पास। हमने सिस्टम को एवेलुएट करना है ना। यूजली बेंचमार्क डेटा सेट्स या वैल्यूएशन डेटा सेट्स वुड हैव डजन्स टू हंड्रेड्स ऑफ क्वेरीज। हर एक के लिए फिर आप निकालेंगे, उनका एवरेज लेंगे और फिर आप एक प्लॉट करेंगे या एक मेजर निकालेंगे एंड देन कंपेयर इट विद अदर सिस्टम। सो वी आर ट्राइंग टू फाइंड द बेस्ट सिस्टम।
ठीक है।
सो इट्स नॉट लाइक टू computationally expensive, गिवन आजकल के दौर में आपके पास यू हैव एक्सट्रीमली लार्ज सिस्टम लाइक न्यूरल नेटवर्क सिस्टम दैट आर ट्रेन्ड। ये तो कुछ भी नहीं है। ऑलराइट, okay, I was mentioning this, so you have to make a judgment call and do an interpolation। ठीक है, तो आप इंटरपोलेशन .1 एंड .2 की आप जो भी प्रिसीजन है उनके .16 पे आप निकालेंगे और वो वाली एवरेज यूज करेंगे, वो वाली यूज करेंगे प्रिसीजन टू एवरेज। ठीक है, सिमिलरली फॉर अदर केसेस एज वेल, द लीनियर इंटरपोलेशन वुड बी फाइन। अच्छा, लेट्स मूव ऑन टू द नेक्स्ट मेजर। आई टॉक्ड अबाउट रेसिप्रोकल रैंक। ठीक है, सो क्वेरी 1 मेरे पास था, रेसिप्रोकल रैंक लुक्स एट द फर्स्ट रेलेवेंट ओनली। ठीक है, सो क्वेरी 1 का फर्स्ट रेलेवेंट हमारे पास किस पोजीशन पे आया था? 2 पे आया था। लेट मी राइट दोज रैंकिंग्स, 2, 3, 5, 8, 12 एंड 15। ठीक है, सो आर आर वुड बी रेसिप्रोकल रैंक 1/2.5। ठीक है, लेट्स से इफ यू हैव मल्टीपल क्वेरीज, लेट्स से दो क्वेरी हैं, एक Q2 भी है मेरे पास। इसका जो हमने ऊपर लिखा था, इफ आई रिकॉल प्रॉपर्ली 3 था शायद, 3 पे पहली आई थी वैल्यू, देन वी हैव 6, 7 एंड सो ऑन। इसका आर आर क्या होगा? इट विल बी 1/3। सो इसका एम आर आर बेसिकली वुड देन बी 0.5 प्लस 0.33 डिवाइड बाई 2, एवरेज ऑफ दीज टू। तो ये मीन रेसिप्रोकल रैंक। So this is a good measure, I would say, especially if uh, you really want to focus on the first relevant document. Okay, if your system gives you the first relevant document way down in the list, so that would not be a good system. And it's a very quick measure, meaning that you just had to look at the first relevant document and not the complete list. Okay, and then we talked about the ranked precision. Of course, for this, you have to specify the rank. Ranks precision at rank, let's say 5. ठीक है, so for Q1, to rank precision at rank 5, Q1 क्या था हमारे पास? 2, 3, 5, 2, 3, 5 था। तो at rank 5 हमारे पास कितने डॉक्यूमेंट्स आ गए? 3। so 3/5 would be the rank precision. For the second query Q2, उसका rank precision क्या होगा? उसका पहला मेरे पास 3 पे आया था and that's it. Rank precision 1/5 would be your rank precision for the second case. ठीक है, एंड ऑफ कोर्स आपने एवरेज लेना है, दिस इज 2, आप फिर इनका एवरेज ले सकते हैं। सो मीन रैंक प्रिसीजन इज मीन फॉर मल्टीपल क्वेरीज। ठीक है, तो ये MRP हो गया। दिस इज ऑल्सो बेसिकली इज प्रिसीजन एट ए गिवन रैंक। सो हमने जब रैंक 5 कहा था, rank 5, so we find the number of documents that are relevant up to 5, position 5. तो अब पहली क्वेरी के लिए हमारे पास 2, 3 और 5 तीन डॉक्यूमेंट्स रेलेवेंट आ रहे थे, तो वो 3 और 5 बन गया। दूसरी क्वेरी के लिए सिर्फ 3 पे, पोजीशन 3 पे रेलेवेंट था, तो दैट वुड बी 1/5। जो 5 है, you have to specify based on the application. Usually typical values for retrievable cases would be 3, 5 and 10. यूजली आप 10 से ज़्यादा नहीं जाते नीचे इन सर्च रिजल्ट्स। इवन ऑन गूगल द स्टैंडर्ड इज 10 सर्च रिजल्ट्स ऑन वन पेज। ठीक है, सो ऑफ कोर्स वो जो मैंने 3, 6, 7 लिखा हुआ है, सो 3 मीन्स द पोजिशन 3 मुझे पहला रेलिवेंट डॉक्यूमेंट मिला है। ठीक है, तो 5 पोजिशन तक मुझे एक ही रेलिवेंट डॉक्यूमेंट मिला है, तो दैट मीन्स 1/5। वो जो लिस्ट मैंने लिखी हुई है, सो दैट इज अ लिस्ट ऑफ रैंक्ड रेलेवेंट डॉक्यूमेंट्स। ठीक है, ये वाली एग्जांपल जो है, ऑल्दो इट्स नॉट अ बिग डील, बट ये क्विक जो है, मैं थोड़ा सा इसको लिख के ना गूगल सॉरी एक डॉक बना के आई विल अपलोड इट, बिकॉज some of you might want to review it as part of your revision for your quiz. By the way, quiz हमारा एक नेक्स्ट मंडे को इंशाल्लाह होगा इन दिस। यस, so we are only checking up to rank 5, and within that rank 5 only one relevant document was found at position 3, so that's 1/5. So as I was mentioning, so we'll have a quiz on Monday, inshallah, next Monday. So it will cover everything till the next lecture, which is on Wednesday. ठीक है, फॉर्मेट वही होगा, around 15 to 20 minutes and 5 to 6 questions. You can bring a calculator, by the way, but help sheet या note sheets allowed नहीं है, quizzes के लिए नहीं है, exams के लिए हो जाएंगे, but not for quizzes.
सर अगर पॉसिबल है क्विज वेडनेसडे को हो सकता है शिफ्ट, बिकॉज हमारी काफ़ी असाइनमेंट्स ड्यू हैं 28 को, 2 असाइनमेंट्स ड्यू हैं।
कुछ तो रूटीन चलने देना, अभी शुरू हो गए हैं आप, अभी तो दूसरा क्विज है, अदरवाइज ये ना ये रूटीन खराब हो जाएगी। आई वुड से स्टिक विद मंडे, एंड एज यू प्रिपेयर, एंड ऑब्वियसली यू हैव ए वीकेंड बिफोर दैट, सो थोड़ा बहुत आप टाइम मैनेज कर लें इसको। वेडनेसडे करेंगे तो कुछ लोग कहेंगे हमको टाइम नहीं मिला, एंड सो ऑन, सो लेट्स एटलीस्ट नो, एवरीवन नोज कि मंडे को क्विज होगा 2 हफ्ते के बाद एटलीस्ट, अनलेस देयर इज सम एक्सट्रीम सिचुएशन, तो फिर हम चेंज करेंगे। अच्छा, सो लास्ट मेरे पास मेजर रह गया, विच इज एवरेज प्रिसीजन, और उसका जो मल्टीपल क्वेरीज का है वो मीन एवरेज प्रिसीजन। सो दिस इज गेटिंग मोर पॉपुलर नाउ डेज। बाय द वे, आईआर सिस्टम की वैल्यूएशन के लिए ना आप यूजुअली एक मेजर नहीं यूज करते, ये तकरीबन सारे यूज कर रहे होंगे फॉर एनी रोबस्ट मेजरमेंट्स। एक नहीं हम करते, मल्टीपल मेजरमेंट्स हम दे देते हैं। इफ यू आर राइटिंग ए पेपर और रिपोर्ट फॉर एन आईआर सिस्टम, यू रिपोर्ट ऑल ऑफ दीज मेजर्स, नॉट जस्ट वन। सारों की थोड़ी बहुत ही माइनर इंटरप्रिटेशन डिफरेंसेस हैं विच वुड हेल्प इन इवैल्यूएटिंग द सिस्टम। ओके, व्हाट इज एवरेज प्रिसीजन? तो पहले हम जैसे प्रिसीजन एट रैंक 5 की बात की थी हमने। एवरेज प्रिसीजन इज एवरेज ऑफ प्रिसीजन एट एवरेज ऑफ प्रिसीजन एट every rank at which a relevant doc was found। ठीक है, दिस इज फॉर वन क्वेरी। और हमारी वही पहली क्वेरी क्या थी, उसका पहला हमारे पास 2 पे मिला था, 3 पे मिला था, फिर 5 पे मिला था, 8 पे था, 12 पे था और 15 पे था। ठीक है, This was Q1. ठीक है. So what would be the average precision for this? By the way, average precision निकालने के लिए upper limit भी usually provide किया जाता है. But let's say मैं upper limit नहीं दे रहा, let's say. But usually दिया जाता है, जैसे average precision to a maximum rank of 10. जैसे हमने rank precision का बताया था कि at rank 5 or 10 or 15 or so on. But let's say मैं वो नहीं करता, तो then what would be the precision at rank 2? So we want to take the average. So it will be, so we have found one document at rank 2. So 1/2, ठीक है. So how many documents have we found at 3? We have 2 out of 3 at position 3 plus 3 at position 5 plus 4 at position 8 plus 5 at position 12 plus 6 at position 15. And how many were there? 6. So this would be the average precision. ठीक है. So we are finding precision at every rank at which a relevant document was found, and we're taking the average of it. ठीक है. So just to compare up to see where this makes sense. So let's say ये 6 documents मेरे पास पहले 6 में ये आ जाते, तो मेरे पास क्या होना था? 1/1 plus 2/2 plus 3/3 plus 4/4 plus 5/5 plus 6/6 divided by 6. This would be 1. ठीक है ना? The precision is very high, or AP is very high. So it means that this is a good retrieval system. So it has found all the 6 relevant documents in the top 6 positions. And if you have multiple queries, तो हर का आप निकालेंगे ये चीज और फिर average ले लेंगे. So that would be called MAP. So MAP is average AP for multiple queries. ठीक है. So so essentially, so this is as I said, the last measure that we'll talk about, and these are the most common measures that are used in practice. And as I said, in practice we typically we report multiple measures. एक measure से काम नहीं चलता. So precision recall, F measure of a system, फिर reciprocal rank और वो लेते हैं, या rank precision लेते हैं, and then average precision. ठीक है. And of course, for many practical systems and large domain systems, large scale systems, so human evaluation is also done. So actually, this is kind of the current state of NLP research. Evaluation is very important. Practice में भी और research में भी. So evaluation का emphasis होगा इस course में, although it's not very deep in the sense कि इसमें बहुत ज़्यादा theory नहीं है, but evaluation आपके system की अच्छी नहीं है, तो then the system is basically not going to fly in your applications. Okay, so evaluation is critical. So human evaluation भी हमको करनी पड़ती है for many cases. And human evaluation for IR essentially would be you will take a group of people, वो system चलाएंगे, वो जो आपके results आएंगे उनको वो पर rank करेंगे. So human evaluation हम ज़्यादा डिटेल में आगे भी पढ़ेंगे for different other tasks. तो यहाँ फिर मैं इसके लिए मैं नहीं कर रहा, बिकॉज दिस इज मोर और लेस a traditional application IR, it's not the modern application. ठीक है, so that concludes our information retrieval. So any questions? By the way, so this is chapter 11, section 11.1 of your textbook. तो आपने वहाँ से पढ़ना है तो वो आप पढ़ सकते हैं. इसकी स्लाइड जो थोड़ी बहुत ही मैंने फिगर्स वाली स्लाइड्स थी वो भी अपलोड कर दी है, बट इसकी बुक की स्लाइड्स नहीं है. सो इस चैप्टर की बुक की स्लाइड्स अवेलेबल नहीं है, सो आई डोंट हैव द फुल स्लाइड्स. Okay, now let's move on to text classification, the other application. ठीक है. So text classification is by far the most popular application of in NLP or in text mining, and it has numerous uh, applications as well as usages in various settings. Uh, the idea in text classification is that given a document D, so given D, find the label for D from a given set of labels. ठीक है. वेरी सिंपलिस्टिक सेंस में आपके पास एक डॉक्यूमेंट है, कोई आपके पास सिस्टम होना चाहिए जो उस डॉक्यूमेंट को लेबल कर दे. ठीक है. और लेबल आपने पहले प्री स्पेसिफाई किए हुए हैं. एंड so let's first quickly look at some applications so you get an idea. Of course applications can be really quite diverse. तो ये जो अभी मैं दिखाऊंगा ये they are just a sample. One of the most popular application of text classification detecting spam in your email, spam in your SMSs, spam in your WhatsApp messages, whatever. So anything that you receive that you are not that is unsolicited is considered spam. So you are usually in spam detection you usually have a textual content, and given the textual content you would like to give it a label. What is the label? Spam or ham, or meaning that spam or not spam. So there is an example here. So this is like an email. So someone writing an email, and there is some information there. So based on this writing, we want to determine whether this is a legit email or a spam email. So this is a typical application, and this one is quite streamlined nowadays. So most applications are built in spam filters. Your Outlook would have a spam filter. Any other application you have would have a spam filter. Okay. So given the textual content, we want to label it. And there are two possible labels, spam or not spam. So this is another application trying to determining the authorship of a document. And this example is from US history, which I'm not very familiar with. But from the slides, so there were some documents or articles written by some people that were anonymous way back when the US Constitution was built. So, but obviously each author has a particular way of writing, style of writing. So in 1963, someone was able to uh, figure out who those articles were, who are the authors of those particular articles. Okay. So again, so given an article, It might be small or large. And given a set of possible authors, we want to find which is the best author for that article. So this is classification. And as I said, so this has been used in this particular application. You can have other applications as well. We're trying to figure out from, let's say, social media post, whether a particular message was posted by some X person or by some Y person or by some Z person, for example. Okay? So another very popular application of text classification is sentiment classification or polarity identification. And I think all of us rely upon this before buying any service or product. So there are reviews out there on the web. Uh, most of them are automatic, and of course, others are done by humans. But we are mostly focusing here on automatic. So someone has written a review of a movie, and we want to determine whether this is a positive review or a negative review. So this is another application. So automatically, uh, given you feed this review into a system, and the system will tell you that this is a positive review or negative. And of course, reviews can be written in ambiguous ways as well. Obviously, language is ambiguous in general. So you have to be, the system has to be clever to really find out whether a particular review is positive or negative. Just a second. All right. So text classification, as I said, its application is as much as you can imagine. So, for example, you can assign the topic or find the topic of a particular document. So maybe let's say you have a library system and you have articles that are written in different topics, maybe from the social sciences, maybe from computer science, double E, whatever your granularity of topics is. So you will need to have an automatic system that can categorize that this article is a computer science paper, this article is a social science paper, this article is a business paper, and so on. So you can classify on genre as well. You can classify based on other things like whether a particular tweet expresses sarcasm or not, for example. So sarcasm detection is also a classification problem. So nowadays, for example, moderation is quite important on social media platforms. So you need to determine whether a particular tweet or uh, message is hateful or not, or offensive or not. So that would be classification as well. So gender identification is another classification problem. So based on the writing, can you determine whether this is written by a male or a female? So again, as I said, applications is really wide. मेडिकल डोमेन में चले जाएं तो वहाँ भी आपको एप्लीकेशन मिल जाएंगी, सोशल साइंसेज में जाएं तो वहाँ भी मिल जाएंगी. Of course, if you come back to NLP, so you can use text classification to determine whether a particular text is written in Urdu or English or Latin or Greek or whatever, so language detection. So this notion of classification can be extended in many different ways. So you can even use classification to determine whether what is the next word going to be in a running text, right? And this is the basis of language modeling, which will start in a couple of lectures. Language modeling. So what is the most likely next word that would appear given a particular context? So that's also classification. So from all possible set of words, what is the best next word that follows a given context? That's also classification. And of course, you can use this for other things as well. Let's say आपका जो next word है वो end of sentence है कि नहीं है. So then this can be used for sentence uh, ending, finding the boundaries of sentences. ठीक है, whether this is the start of sentence or end of a sentence and so on. ठीक है. So as I said, numerous applications as your imagination can find. All right. Any questions? So modern text classification is entirely machine learning based. So and more specifically supervised machine learning. ठीक है. So supervised machine learning, I will give a quick overview. Uh, and this overview is more probabilistic overview, but I think probabilistic would capture the notion of supervised machine learning in a better way. You can give a pure statistical overview as well, but मेरे ख्याल से I think I'll stick to this. So what is the notion? So we have we have each document. So each document is represented as a vector, let's say x. And जब भी हम वेक्टर की बात करते हैं यूजली वो बोल्ड फेस्ड होता है, बट इन माय क्विक राइटिंग आई विल नॉट बोल्ड फेस्ड इट. ठीक है. सो वेक्टर एक्स इज द रिप्रेजेंटेशन फॉर अ डॉक्यूमेंट. सॉरी, वेक्टर एक्स इज अ पर्टिकुलर डॉक्यूमेंट. ठीक है. एंड द आउटपुट लेबल would be represented by the variable y. And we will start with binary classification, and this would essentially be in basically 0 and 1 or some two other labels. So these labels are arbitrary. 0, 1 मैंने अपने convenience के लिए use किया. It could be positive, it could be negative, it could be author X, it could be author Y, and so on. So this is binary classification. There are only two possible labels. ठीक है. So any such classification problem can be represented probabilistically as a distribution over these two variables, x and y. ठीक है. So if you know this distribution, obviously you can answer all questions regarding any particular x. But do we know this distribution? So this distribution captures all uncertainties in this classification problem, where you have x as the input and y as the output. So if you have this probability function which gives you all probability values for all possible values of x and y, you can answer every, or you can solve every classification problem. But we do not have this distribution, so unknown. ठीक है. What we do have is a data set. ठीक है. तो डेटा सेट आपके पास टिपिकली क्या होता है? इट्स पेयर्स ऑफ I is equal to 1 to n. ठीक है. And we assume, although this is in reality, we would like to ensure, but we assume that this is drawn from that distribution without any bias, which in statistics and probability term हम कहते हैं IID है, from P. ठीक है. Independent and identically distributed from P. It's assumed, but generally थोड़ी सी variations होती हैं, but we can't do much about that. ठीक है. So any questions? All right. Okay. So we usually have this data set and we don't have the distribution. So our task would then be to learn our or estimate that distribution from this data set. Once we have the distribution, let's say once you have found probability of x and y, an estimate of this, जिसके लिए मैं let's say मैं p star कह देता हूँ, is an estimate learned from data set. Once you have this, then you can make a classification, right? आप probability rules लगा सकते हैं and then given an x, you can find a y or you can find, so for example, let's say given a particular x, you will have both probabilities, x, y is equal to 0 or probability of x, y is equal to 1. So इसकी best class label क्या होगा? ये दोनों probability आपके पास होंगी तो फिर best class label क्या होगा for x? Based on probability theory, the one which is higher, right? So a probability of x, so let's say if this is 0.3, and then of course since there are only two possible values, this would be 0.7. तो आप x को class 1 कहेंगे because this is the most probable label for this observation x. ठीक है? And this step that I mentioned here, this is called the learning step. And this is basically called the inference step. Okay? So this is the probabilistic view of supervised machine learning. So there is some unknown distribution over your inputs x and the class labels y. We estimate this distribution from a data set which we assume to be faithful to that distribution. Of course, but it's limited, it's finite. Distribution generally implies it's infinite. So we estimate this and we call this p prime. Let's say we have found this in some way. Once we have that p prime, we can then make a decision regarding any new x. So given any this new x, we find the two possible probabilities, y is equal to 0, y is equal to 1. So the probability, the the so the label for which the probability is high, so that would be the best for that particular x. Okay. All right. So any questions so far? Uh, so when we talk about representing each document as a vector, you can think of it exactly as TF-IDF. So that is one way of representing D as X. There could be other ways as well, but as we saw for IR, TF-IDF works well, and for many simple applications, TF-IDF also works well for text classification. So TF-IDF is a vector over the vocabulary space. And of course, we computed it's how to compute it. So this would be the X for any particular document. As we discussed before, TF-IDF would be a bag of word representation. So there is no notion of location of a word in a particular document. So each location, each feature in this X is actually a token in your vocabulary space. So that token could be a subword, it could be a character, it could be two words together, which we actually call bigram. It could be a word, which is the most common way of using, uh, of building a vector, and so on. Any other question? Okay, now a quick overview of logistic regression. I guess most of you must have studied logistic regression at least one other course before this. Is that right? So किसी को ये ठीक है, so किसी को ये नाम weird लग रहा है? ठीक है. Okay. So logistic regression is a fairly powerful text classification or a general classification technique. It's a probabilistic classification technique, and so so it's used for classification, but it's called regression. So, and I guess linear regression आप सब ने लोगों ने पढ़ा होगा. So, for example, a function like y is equal to w naught plus w1 x1. By the way, जब मैं x1 लिखूंगा, this means that x subscript 1, and this refers to the feature of that vector x. So हमने vector x कहा था ना, representing each document x1, it would be one particular feature plus w2 x2. So in this case, we say that there are only two features. So vocabulary size 2 है या दो features हैं आपके, which of course for text classification is a bit too low, but just to explain this. ठीक है? तो इस तरह के आपने functions पढ़े होंगे, but this was typically called linear regression, right? ठीक है? So y here was a real number, a scalar real number. It was a continuous number. ठीक है? So that's why it was regression. In logistic regression, as we will see later, y would still be a real number, but we will ensure that that real number is a probability value. So once it's a probability value, then you can use it as we discussed earlier to find the class of a particular document. But let's going back to this. So what are these W's? So these are called parameters of the model. Happened. Okay, can you guys hear me?
Yes.
अच्छा आवाज आ रही है, ठीक है. I don't somehow, ठीक है. So these are called the parameters of the model. ठीक है. And in general, given data, of course, this data would be different from any other the data I mentioned earlier. We would like to find the best values for these parameters. Once we have these values, then we can use this equation to make predictions. Okay. But here, of course, as I said, y is a real valued number which can take on any value from negative to positive. So we would like this to be a probability. So this is where the sigmoid function comes in, which is a very, you can say, fundamental function in neural networks as well as in logistic regression, in classification, in probability theory. So this function is an S-shaped function. So the sigmoid function, so let's say sig of some value z, of some variable z, is basically 1 divided by 1 plus exp, the exponent function, minus z. So z is a scalar, ठीक है? Z is scalar, and the sigmoid function is defined by this expression 1 over 1 plus exp, e raised to power of minus z. So exp is the exponent function. ठीक है? So इसको मैं z कर देता हूँ. Let's say I use this in the, ठीक है? And I use this sigmoid function z का. This essentially then becomes your logistic regression. ठीक है? And output now would be squashed between 0 and 1. So sigmoid function का आपको दिखा सकता हूँ. So this is how the sigmoid function looks like. This is like an S function. On the x-axis, we have z, which is, as I said, a scalar. It's a real value number, just like y that we said earlier, but now I've changed it to z. ठीक है? और y पे आपके पास output of the sigmoid function. So output of sigmoid function, as you can see, is now squashed between 0 and 1. So when z values is 0, z की value 0 है, तो then it has a value of 0.5. This is where it intersects the y-axis. ठीक है? But when z की value very high पॉजिटिव पे जाते हैं तो सिग्मॉइड का फंक्शन 1 पे लिमिट हो जाता है. इफ z की वैल्यू वेरी स्मॉल नेगेटिव्स में जाते हैं तो ये लिमिट हो जाता है 0 पे. एंड एज यू कैन सी दिस इज अ स्मूथ फंक्शन. ठीक है? इट्स कंटिन्यूसली डिफरेंशिएबल, which is of course useful for learning in a neural network context as well as in logistic regression. So now a continuous output, which is a real number, has now been transformed into an output between 0 and 1. And of course, you know that an output between 0 and 1 is a probability, or it can be considered as a probability, right? So what happens is, okay, so what we do now is we take the left-hand side, instead of giving it a continuous value, we say this is actually the probability of y is equal to 1 given as the conditional probability. This is basically a sigmoid of z, or 1 divided by 1 plus exp minus, फिर एक मैं parenthesis डाल देता हूँ, w naught plus w1 x1 plus w2 x2. ठीक है? So this expression is expression for logistic regression for binary classification. Notice that the output on the left-hand side is a continuous value. So that's why this is called regression. Continuous value. But your continuous value is squashed between 0 and 1. So we can consider this to be probability and use it for classification. Okay? So now you have a complete formulation of logistic regression in terms of its parameters. W0, W1, W2. Of course, for a real world text. Yes, that's right. For binary classification, that's right. So the probability of y is equal to 0. Since there are only two possible values, from probability theory, you know that uh, all probabilities should sum to 1. Since there are only two probability, you know the probability of 1, the other one would be 0, and x is given. So given में जो मर्जी हो, in this case, this is one document or one classification example. ठीक है? So this is the formulation. Now the task, of course, is given data set, find the parameters W's. Okay? So this would be as I sort for learning or inference. Okay? So we have a parametric model because we have parameters. We have a parametric model, but this is a probabilistic parametric model. And more specifically for those who know more about machine learning, this is a discriminative probabilistic model, not a generative model. We are directly finding the posterior probability of y given x. Okay? So it's the posterior probability of y given x. We're not finding the likelihood x given y, or we are not finding the joint distribution of x and y. Okay? So I think ये थोड़े से learning का part फिर मैं next class में discuss करूँगा. Again, I won't go into much detail. Slides इसकी मैंने upload कर दी हैं. Slides आपने go through करनी है. After completing this, I'll quickly introduce feed-forward neural networks, and then we'll talk about evaluation, and then we'll move on to other topics. Any questions so far? Any questions? Question किसी का था? Sharing. So if there are no questions, then we can. Okay. So we'll discuss maybe with an example of a movie review. In general, as I mentioned, the labels are arbitrary. जो 0 1 मैंने दिए वो numbers for convenience है. 0 could be positive, 1 could be negative, 0 could be spam, 1 could be ham, depending on the application.